My name is Mo, and today we are going to continue with our tutorial on NLP. So in our first session, we talked about natural language processing, and we got a data set. We imported the data set, and then we started cleaning it. But today, after cleaning the data set, we are having this kind of data frame that you can see here in our screen. This is the tweet that we had, the original ones, and this column is the clean one, and I think that's enough for now. So we're gonna go for the next steps, and we're gonna go for tokenizing the data frame, each tweet, and then we're gonna go to limitizing and stemming. Maybe these are new concepts for you, but we're gonna learn how to use them and why they're important here. So if you don't know what is tokenization, it's not important. We're gonna cover it right now. So very simple. I want to just show you what is tokenization. So let's see. This is the sentence, and this is the sentence that we have, and it's clean. So if we split it into different words, like when a father is like this is kind of our tokens that we have. So splitting a text into different words is called tokenization. And for this reason, we can use a lot of some libraries, and I'm gonna introduce you to Natural Language Toolkit, NLTK. So import NLTK, NLTK, sorry. And we can also import tokenizers from NLTK. So I just wanted to show you how to import NLTK from NLTK import. So if you go for the token, you just write token. So you're gonna get a lot of things with tokenizers, right? So let's see what we got here. Okay. Nice. Okay. So we're gonna go for word tokenizer. There are a lot of tokenizers here. There is also a tweet tokenizer for this case, and we can just compare them. I think this is not really different. So let's go like our last session, just choose one row and apply this and see what the result look like. So I'm gonna go for the text one again, and I'm gonna call this row first row cleaned. So our data frame is df dot cleaned, and I'm gonna go the first row to see how does it look like. So sorry, I should run the whole thing again. Okay, that's it. And yeah, here we got our first row of data set. It's clean and it's ready to use. So if we apply this tokenizer, we can see that let's go for word tokenize, and we're gonna tokenize this here, and see this is the list. And I'm gonna call it something like tokens more than one. Okay, and I'm gonna also use the other one, this tweet tokenizer. So tweet tokens. I just want to see what is the difference. Maybe it's I don't know if it's important or not. Sorry. Text one, and here we are gonna print them. So print tokens, and also print tweet tokens. I just want to see. Oops, sorry. I think here I should use something like this. Yeah, that's it. So these are the tokens, like normal tokenization, and the second one is tweet token. And let's see if there is a difference. I'm just like examining them. This is like 100% same. I mean, it could be different in some other cases, but I wouldn't recommend to like use tweet tokens, because I think word tokenizer, I have used this before many times and it's working perfect, so you don't need to like be worried about that. So here we just want to apply this to the whole data set, right? So our data frame, and I'm gonna call it tokens, right? And so we are gonna read it from our this column here, cleaned. And I'm gonna apply all this function, which is really easy here for tokenize. And let's see if it's working. Okay, so let's see the data frame first. So we got the tokens here, right? This is the tweets, clean one. Clean one is here, and these are tokens. So not really complicated, just splitting a text into the words. And next step is going for lemmatization and stemming. If you're not familiar with this concept, it's not really complicated. It's just like getting the root of the word. So if it's like I don't know, plural name, or like I don't know, verb with ing or something like that, it gets you to the the root of the word. Let's see here. I have an example. Like it, and on the left side you can see how stemming works. Like for 4 different words starting with develop, it returns you like develop here. But lemmatization is a little bit complicated, and I would say better, because it considers the context and it returns something that usually makes more sense than stemming. And we're gonna try to see why I'm saying that lemmatization is better than stemming. So we are gonna use NLTK again, from NLTK import. So we have WordNet lemmatizer and stemming. Stemming has like different, like we have different stemmers here, but I'm gonna use only Porter. You can try like other stemmers to see if they are working better or not. And our rule is to choose the first row or some other rows and test this and see how the result reflects, just like the other like steps that we have already done. So tokens, and I'm gonna call it df tokens. So let's go for S here as well, and just the first row, right? This is the list of words, and now I'm gonna like apply both WordNet lemmatizer and Porter stemmer on. So here I'm gonna need 2 lists, because it's a list of words, and after like lemmatizing or stemming, we're gonna get a list again. So let's go for lemma list, and let's go for stem. Sorry, list, and yeah, it's gonna look like this. And for item in this list, which is tokens, so it should be 4. Okay, it should be tokens. So what we're gonna do, it's really simple. It's like using both these functions. So I'm gonna call the output lemma, and this is how it works. So lemmatize, and here goes item, and then you can simply add it to lemma list, right? So lemma list that appends lemma, right? The next one I'm gonna do for stemming. So stem is porter stemmer, right? This is also like an attribute of this function, so it's stem and item, and I'm gonna add the result to this list so you can see that the difference. I think that's it. Okay, so let's see lemma list. Let's print them down, and I'm gonna print stem list here. Let's do something and print original one, right? Tokens. And yeah, here we got the original list, like tokens that we had. This is lemmatized, and this is a stem. So far as I can see, they are the same, and here is one difference. And see, this functional, here it is dysfunctional, but here it is dysfunct, which I don't know if it's a word or not. Looks like a word. So here this is lemmatization again. So the second row, and is it's the same. So selfish, he, and drag is the original. This is drag, this is drag. So far they look like each other, and he's, but you see here in the stemming it's high, like it's like changes the meaning of the word, right? So this is one of the issues with stemming. Kids, kid, into. Again, here we have his, here is again high. So far we had like 2 positive points for lemmatization, but stemming, yeah, it's not really good. And again, same word. So you can like try this on different, like let's go for just 5. Don't know what is that. So these are numbers: huge, fan, fair, and big, talking, talk. So I think here, like, I think talk is better than talking if it's gonna get you the root. I don't know before, but here you see we lost E after before, and this is stupid. They leave, you see it's leave is also doesn't make sense, not a word. Or chow, change the meaning of the name. Okay, it's the same. Dispute without an E, and yeah, no, we got a lot of issues with the stemming. That's why I'm saying that lemmatization is 100% better than stemming, and I show you how to like you can compare them, right? So I'm gonna apply this lemmatization to the list, to our data frame. So our data frame and lemma is equal to let's say df and tokens. It's tokens dot apply, and we're gonna apply this, but it's a list. We are not applying it to one item in each row. It's actually, it should apply itself to all items in a list in one row. So it's we are here can use lambda of x, and it works like as it is a list. I'm gonna say this is exactly same thing that we used here, right? But we don't have item. Item is not defined. So for item in x, so every row which is x here, it looks for items in x. So every word like this, and then it applies this word limitizer to every and each of them. Okay, and let's see what we got. Cool. And we have our tweets. It's clean. We tokenize them, we limitize them, and in next session we are gonna go for removing stop words, and then we're gonna start with like our machine learning model to classify these tweets into hate speech or not hate speech. Thank you for watching. Please like and subscribe my videos.